tree structure. And then,
Does it have to be in Java?
no, you guys can write this in whatever you want. I just did this in Java because I like writing Java and it's pretty quick. And, I mean, this doesn't compile, or it probably compiles, but it doesn't run because there's no code in it. It's just meant to kind of give you guys an idea of how you would want to attack it. And then the other one is like the main class that would actually run. So basically you would start with, you know, whichever player you're trying to determine the best move for. So this is the play function where you would actually go and try and find the best move. And so find best move would be the min-max algorithm. It'll actually go through, traverse down the tree to all the different child nodes, evaluate the ones at the bottom, or however deep you're going to go, and then propagate those values back up the tree to figure out which one is the best. If you want, you could do alpha-beta pruning. It's not necessary if you don't want to. And so there are functions in there to do that, or there's skeleton functions in here that you could use if you wanted to. Obviously, part of optimizing your search is to try and find the best moves first. So as you're building that tree, if you can search for the best nodes first, you know, the best moves first, you could actually get values that will eliminate the further ones down the line. So if you find out that, like, oh, you know, these 5 moves in general will give me the best results every turn, just check to see if you can do those first. Then compare to what the possible maximums are for all the other branches. You could eliminate them off the map. There's a function here to just print out the board. So in this case, a command line program. You could also put a GUI on this if you wanted to, in which case you would just be updating the board once a turn. Yeah, so in your search you're going to try all the different children, and then just kind of add them to a list, go through them one by one until you've evaluated them all, and then update the parent. And then 2 separate functions for when you're doing a max value versus a min value. So in one you'd be looking for the lowest number, and the other you'd be looking for the highest number, and you could take the alpha-beta search into account there to eliminate ones based on what type of search you're doing at the time. So I just confused the hell out of you, right? Everyone's like, I'm doing project option number 1. So if you look at project option number 2, you don't necessarily have to do all this. You could just do a simple heuristic whereby you would try and come up with the best possible rule set that you think you could for the game, like what move would I want to do first, and write a simple program that would do that. So in the case of tic-tac-toe, you know, you would say, you know, maybe the center piece is the most valued, and evaluate out of all your possible moves what is the best move you can make.
What is the final move?
The project or the final? It's a week before the final. Oh, I do have it.
May 12. I thought it was like May 6th.
Yeah. So the final project is due at the end of this month. It's the 29th. And the final is the 6th.